Guys, today we're gonna discuss about solving quadratic equations by completing the square. We know for the fact that there are many other methods on how to solve quadratic equations. That's by the use of quadratic formula and by factoring. But for now, we shall focus on finding the roots of quadratic equation by completing the square. So are you ready? Let's go. This time we'll go to example number 1. Use completing the square method to solve for x squared plus 8x plus 7 is equal to 0. Notice that x squared plus 8x plus 7 is equal to 0 is also factorable. So meaning to say, we can also solve this by using factoring. At the same time, this can also be solved using the quadratic formula. And of course, we can solve this by using the completing the square method. But this time, we'll focus on completing the square method. Now, um, all we have to do in this quadratic equation is to combine, or we have to isolate the constant to the other side, and terms with the variables will be on the left side and constant on the right side. So we're going to subtract 7 to eliminate 7. So from both sides, so we have x squared plus 8x. This is 7 minus 7, that's 0, is equal to 0 minus 7 is equal to negative 7. Okay. Next step, notice the numerical coefficient of x is 8. Now we're going to divide this by 2 or multiply this by 1/2. No? So we will have to divide this by 2. Divide by 2, 8 divide by 2, and then square it. And the result is 16, which will be added to both sides of the equation. Okay, so we have 8 squared plus 8x plus something equals negative 7. So we have plus 4 squared plus 4 squared. The reason why we divide this by 2 and then square it, and the result will be added to both sides, so that this will become a perfect square trinomial. Okay, so this is equal to x plus 4 times x plus 4, or quantity x plus 4 squared, because when you take the product of this is equal to x squared plus 8x plus 4 squared. So negative 7 plus 16, that's positive 9. Now we're going to eliminate the square. So all we have to do is to apply the square root property. We'll take the square root of x plus 4 squared and 9. So we have the square root of quantity x plus 4 squared is equal to square root of 9. Y squared property, so that we can remove the 2, or we can cancel the 2. So in this case, cancel out the radical sign and square. Okay, and that's equal to x plus 4 is equal to plus minus 3. Because the square root of 9, this is equal to plus minus 3. Alright? So we have x plus 4 is equal to 3, or x plus 4 is equal to negative 3. Notice that the roots are, there are two roots here, no? Because we're solving for quadratic equation. The degree of this polynomial is 2, so meaning we have two solutions. Now, first, x is equal to, we're going to subtract 4 from both sides. So this is equal to 3 minus 4. So x now is equal to 3 minus 4. That's x equals negative 1. So meaning this is one solution. Let's go to the other one. X plus 4 minus equals negative 3. So we're going to subtract 4 also from both sides. So we have x is equal to negative 3 minus 4. That's x is equal to negative 7. Okay. Now, we're going to verify if negative 1 and negative 7 satisfies the original equation. So, meaning we're going to substitute for the value of x, which is negative 1 and negative 7, to the original equation. Okay, if x is negative 1, you square it, that's positive 1, plus 8 times negative 1, that's negative 1 times 8, negative 8, plus 1, that's negative 7, plus 7, so 0. So, meaning this is true. Okay, let's go to x is equal to negative 7. Okay, negative 7 squared, that's positive 49, plus negative 7 times 8, negative 56, plus 49, so negative 7 plus 7, that's 0. So, when it say negative 1 and negative 7 are roots of the quadratic equation. Alright, let's go to example number 2. Use completing the square method to solve for 6x squared plus 5x minus 6 is equal to 0. Notice that the numerical coefficient of x squared is 6. Okay, so make sure that the coefficient of x squared is 1. So in this case, our numerical coefficient is 6. So we're going to divide both sides of an equation by 6. Okay, so we have, all right, 6x squared divided by 6 plus 5x divided by 6 minus 6 divided by 6 is equal to 0 over 6. We're going to simplify this. This cancels 6, so we have x squared plus 5x over 6, or 5 6x minus negative 6 over 6, that's negative 1, is equal to 0. Okay, next step, we're going to isolate negative 1 by adding both sides of an equation by 1, because we will have to combine terms with numerical coefficients, terms with variables, I mean, to the left side, and constant to the right side. So we have it's 1. Okay, so x squared plus 5 over 6x, negative 1 plus 1, that's 0, is equal to 0 plus 1, that's positive 1. Okay, next step, um, the numerical coefficient of x, we're gonna divide this by 2, or we can multiply this by the reciprocal of 2, which is equal to 1/2. Okay, so 5 over 6 times 1/2 is equal to 5 over 12. Okay, and then you have to square it. Okay, so the result of this will be added to both sides of an equations. It's 1, no? So we're gonna add 5 over 6, I mean 5 over 12 squared to both sides of an equation. So we have x squared plus 5 over 6x plus 5 over 12 squared is equal to 1 plus 5 over 12 squared. Okay? Okay. Next step, this is equal to 5 squared. That's 25. 12 squared, that's 144. Okay, so we'll have to substitute um, to 5 over 12 squared later. Okay, so we have x squared plus 5 over 6x plus 5 over 12 squared plus 1 plus 25 over 144. Okay, we're gonna simplify. So we have x squared plus 5 over 6x plus 5 over 12 squared. This is equal to 144 times 1, that's 144, plus 25, that's 169 over 144. Notice that this is now a perfect square trinomial. So this is equal to x plus 5 over 12 squared, because when you multiply x plus 5 over 12 times x plus 5 over 12, the product is x squared plus 5 over 6x plus 25 over 144. So this is 169 over 144. Next step, we're going to get the square root of the terms in both sides. So this is the square root of quantity x plus 5 over 12 squared is equal to plus minus the square root of 169 over 144. Okay, let's go to the next. Still in example number 2. Um, we will have to cancel the radical sign the square. So that's equal to x plus 5 over 12 is equal to plus minus square root of, we'll take the square root of 169, okay, and the square root of 144, so that's 13 over 12, of course this square root, so plus minus. Okay, so our solution now is x plus 5 over 12 is equal to positive 13 over 12, or x plus 5 over 12 is equal to negative 13 over 12. Okay, we'll solve this first. So we're going to Subtract both sides of an equation by 5 over 12. So x is equal to 13 over 12 minus 5 over 12. Since we have similar fraction, so we'll have 13 minus 5, that's 8 over 12. Okay, so that's 2/3. We further simplify 8 over 12, that's 2/3. Okay, next solution. We subtract both sides of an equation by 5 over 12. So we have x is equal to negative 13 over 12 minus 5 over 12. Okay, this is similar fraction. So we have x is equal to negative 13 minus 5, that's negative 18 over 12. This is reducible. So this is equal to negative, divide this by 6 by 6. So we have negative 3 halves. Alright, so that's our solution. 2/3 and negative 3 halves are the roots of the quadratic equation. So before we end, I'd like to summarize the rules, okay, on how to solve quadratic equation using completing the square method. Thank you guys for watching my video. I hope you enjoyed the mathematics lesson. And don't forget to subscribe if you think the video is very useful. And stay tuned for more exciting videos about mathematics, probably algebra. Right? Thank you and bye.